Alright, so in this video I will be talking about how you can interchange information between the three forms: general, standard, or also known as vertex form, and x-intercept form. So as you can see, I've given an example of an equation. I've got y equals x squared plus 4x plus 4. And the next one I've given you the standard form with x plus 2 squared. And the last one I've given you the x-intercept form, x plus 2 times x plus 2. So each of these will give us different kinds of information. So I'm just gonna, in this video, list them off of what you can find with each. So the first form here, you have y equals x squared plus 4x plus 4. So here's a couple things that you can note. First, if you look at x squared, this value, depending if it's positive or if it has a value higher or lower than 1, that's going to show you the opening of the parabola and how thin or how much the parabola is going to open. So right here it's just x squared, so we've got a nice and easy one. So that means that if it's positive, it is opening upwards, and the it's going to be the minimum. The vertex is going to be the minimum of the parabola. Also, since it's 1, this means that it is only going up by 1, 3, 5, 7. So the pattern's going to stay the same. It's going to keep the base. It's going to keep the y equals x squared form. So it's going to go up 1 over 1, up 3 over 1, and up 5 over 1, etc. So if that number were to be 2, it would go up 2 over 1, up 4 over 1. Sorry, up 6 over 1, and up 10 over 1, etc. Right? So that, depending on that number, we'll know what we get. If it were to be a negative number, that means that the vertex would be a maximum on the graph, so it would be pointing downwards. And we can also find that the plus 4, the very last number there, shows us our y-intercept. So that is where it's going to cross the y-axis. For our next form, we have y equals x plus 2 squared. So what this is going to show us actually is our most important form. That's why it's also known as vertex form. So you've got x plus 2 squared, and there's nothing else. So before, I showed you in the equation that x squared at the very top one meant if it was opening up, down, if it was getting thicker, thinner, if the vertex was at maximum or minimum. So same here, except this is going to show us that if there's a number in front of the x plus 2 squared, then we're going to treat it the same as x squared in the first equation. So if there was a number 2 in front of that, we'd go up 2 over 1, up 6 over 1, and then up 10 over 1. But it's not going to look the same, but it actually acts the same. Now, the plus 2 inside of there just means that the plus 2 and the number that would be to the right of that, outside of the brackets, which right now isn't there, is going to show us our vertex. So this shows that plus 2, so for some reason we will always go, let me correct myself, because it is plus 2, we're actually going to go to the left. So when it kind of tricks your brain, but if it says plus 2, you're actually going to find the vertex on the negative side, and if it's negative 2, you're going to find it on the positive side. So you're always going to do the opposite. So if it's plus 2, that means that it's going to be x equals negative 2, and then since there's no value next to it, we're just going to assume that's 0. So the vertex of the equation would be 2 spots to the left, and it would stay on the y-axis. The last version is the x-intercept form, which basically shows us how to find our x-intercepts. So we expand our equation, and we get x plus 2 brackets times x plus 2. So all we have to do to find the x-intercepts here are find a number that would make that bracket equal to 0, because if it multiplied the other one, that would equal 0 as well. So you're going to look x plus 2, so to get 0 in that bracket, we're going to have to subtract 2 to equal 0. The next one, luckily, it's going to be the same thing. So those are the 3 types of equations you can have, and those are the amounts of information that you can get from those 3 types of equations, and they're all interchangeable, and that's what I wanted to share with you this week. So thanks for listening.